Hello everyone, this is Lecture 2 of ComSci 174, OpenCV. In today's video, we will discuss the tool that we will use for ComSci 174, which is OpenCV. We will look at its basic operations, we will learn how to draw in OpenCV, how to do image manipulation, image arithmetic, and do some image transformations. Okay, so this will be a rather short discussion, a short lecture, and then we will go to the demos so that you can see how it is done in OpenCV. Okay, so let's start. So what is OpenCV? Okay, OpenCV is an open source computer vision and machine learning software library that is implemented in different languages, and these are C++, Python, Java, and MATLAB. For our course, we will be using OpenCV with Python. Okay, you can use it in different operating systems like Windows, Linux, Android, and Mac OS. Okay, so whatever OS you're using, OpenCV is usable in that environment. Okay, so it is one of the most popular computer vision libraries out there. Now, some dependencies for OpenCV in Python are the following modules. So NumPy, it's used for handling multidimensional arrays, because basically an image is just a multidimensional array, right? So NumPy is used for that. And then you have SciPy, which is used for scientific computing, and Matplotlib, which is used for plotting some graphs. Okay, so those are just some of the dependencies that you'll need to install for OpenCV to work. Now, of course, OpenCV is the most popular computer vision tool for Python, but it's not the only one, right? There are also other image processing and computer vision tools that are available, such as PIL, SimpleCV, Scikit-Image, and Mahotas. And this is just for Python. Of course, there are other tools as well in other languages. Okay? Now, let's review images. So, we know that images are made up of pixels, right? So, a pixel is the building block of an image. So, we can think of an image as just a 2D array or grid of pixels. Okay? So, usually, it has 3 channels if it's colored. So, you have the red channel, the green channel, and the blue channel. Or if it's grayscale, then there's only 1 channel. And to access the coordinates, so the coordinate system of the image looks like this. So you have y, x, and then c. So y and x, those are the x and y coordinates. So that would be the row and the column of the pixel. And then c would be the channel. So whether it's on the first, second, or third channel. Okay, whether it's in the red, green, or blue channel. Okay. Now, images usually have this things called Colorspaces. So the default color space is the RGB, okay, wherein the image is made up of red, green, and blue channels. Okay, so for each channel, it will tell you how much red is in that pixel, or if this pixel has a certain color, how red is it, or how green is it, or how blue is it. Okay, so pixels are just intensity or brightness values that range from 0 to 255. Okay, and this is the default color space of each image. Okay, however, in OpenCV, take note that your images are in BGR, not RGB. Okay, so the first channel is actually the blue channel, followed by the green channel, and then the red channel is the third one. Okay, so it's not RGB, it's BGR for some reason. Okay, so just take note of that, because you might want the blue channel and then you access the third one because you're thinking it's in RGB, but it's actually the first one because it's in BGR format. Okay, now some examples of colors in BGR would be black would look like this, 0, 0, 0, because it's 0 in all 3 channels, meaning there is an absence of brightness, so it's pure darkness. Okay, so 0, 0, 0, that's black. Okay, if it's white, then it's full 255 for all 3 channels, meaning it's full brightness or full intensity for all three, that makes it white. Okay, and then red is only has 255 in the red channel, which is the third one, and then 0 for the first two. For green, it only has 255 in the middle channel, which is the green channel, and then for blue, of course, in the first channel, which is the blue channel. And then there are also other colors like yellow. Okay, so yellow has 255 in both green and red, and then aqua has 255 in both blue and green, and then magenta has 255 in both blue and red. Okay, and then 0 for green. Okay, of course, these are not just the only colors, but these are just some of the more the primary colors and then the secondary colors. Okay, of course, any combination of numbers ranging from 0 to 255 in 3 channels would make a unique color. Okay, now that's the RGB color space. Now let's move on to other color spaces, and the two most common ones that you'll be using besides RGB would be HSV and the lab color space. So you're probably familiar with HSV. You've probably heard of it before. So HSV stands for hue, saturation, and value. So what does these three things represent? So hue dictates what color. So is it red? Is it the blue hue, the green hue, and so on? The saturation is what shade of red. So is it a maroon range or bordering on the pinkish shade, right? So yeah, that's saturation. And then the value part is the actual brightness. So is it light or dark? Okay, so that's HSV. Now the last one is lab color space, and you usually convert the image to lab color space if you want to measure the distance between two colors. So if you're doing things like color similarity, it might be useful to convert it to lab color space, because this is when you can easily measure the distance between two colors. Okay, so you'll probably use this in exercises later, but yeah, that's the purpose of lab color space. Okay, so that's color spaces. Now let's take a look at some of the basic operations that you can do with OpenCV. Okay, so of course the first thing that you need to do is you have to load the image into the computer, right? So you read the image. So you do this by using cv2.imread. Okay, so cv2 is the name of the OpenCV library in Python. So you import cv2 and then you can use the methods in the cv2 module. So cv2.imread means that you are reading the image. And then to save the image, then you'd use cv2.imwrite. Okay. To display the image, cv2.imshow. But if you just display the image, it will pop up and then it will disappear right away. So for you to be able to actually see the image without it disappearing right away, you need to use cv2.waitKey, which means that it will pause for now because it will wait for a keystroke, meaning you need to tap one of the keyboard buttons, or yeah, one of the keys in the keyboard for it to continue. Okay, so this is essential when you are showing the image, because if you don't use this, the image will show and then just disappear. So we'll see this later in the demo. Okay, so wait key is waiting for a keystroke, and then destroy all windows will just destroy all the open windows that are showing some images. Okay, by the way, wait key is also used not just for waiting, like for you to continue, but also to get like input from a user. Like let's say you say press Q to quit or press S to save, then wait key will get the letter that you pressed or the key that you pressed, and then if it turns out that you pressed Q or S, then you can process it accordingly. Okay, so we'll see this later in the demo. Okay, what are other basic operations? To open the camera, then you use cv2.video capture with the parameter 0. So if you pass in parameter 0, then it will open the first camera. So if you have multiple cameras, then you pass in the index here. So if you have 2 cameras, then if you want to open the second camera, then cv2.video capture 1. Okay, but if it's the built-in camera, then it's usually just 0. Okay, now if you want to open a video, it's the same thing, video capture, but then you pass in the path of the file, of the video file. Okay, and then it will open that. Now of course this will only open the video, but so you have a video object, but if you want to read the images off of the video, then you would want to use video.read. Okay, so this video here is the object that you save from the video capture. So you would write it like video is equal to cv2.video capture 0 or cv2.video capture path. Okay, so we'll see this in the demo later. But once you have this video object, then you can call the read method to read video or camera frames from this video object. Okay, so those are the basic reading, writing, opening video streams in OpenCV. Now we can also draw in OpenCV. Of course, it's not the primary purpose of OpenCV, but we can draw because later on we might want to mark interesting regions, like during testing. So we might want to mark them with some X or some colors. Okay, so we can do this with the drawing capabilities of OpenCV, and also for writing labels. Okay, and then if you want to create like a blank image, then you can just call np.0. So assuming that you import numpy, numpy was one of the dependencies that I mentioned earlier. So we usually import numpy as np, so as a shortcut. So np, so np.zeros will create a blank image, basically just a matrix of numbers with all zeros as the content of the matrix. Okay, so create blank image, you usually have np.zeros. Okay, but then since it's all 0 pixels, then this will be a blank black image. Okay, so I'll show you this later. Okay, so other drawing functions, we have cv2.line to draw a line, cv2.rectangle, cv2.circle, cv2.ellipse, polylines, and put text. So of course rectangle, circle, and ellipse, those are self-explanatory. For polylines, this will draw a polygon, and then for put text, this will write the text that you want to display. Okay, so those are the drawing functions for OpenCV. Now let's talk about image manipulation. So how can you manipulate parts of the images so that you can maybe change like a patch or like some region of image? Well, first, image manipulation technique that you can do is to change color spaces. So we mentioned that there are different color spaces earlier. So how do you convert from one color space to another? So you use convert colors or CVT color, and then various flags exist, like for example CV2 color BGR to gray. So from the BGR color space, you convert it to the gray color space or gray scale, or BGR to HSV, then it will be converted to HSV, or BGR to lab, so for the lab color space. Okay, now if you want to get the individual channels like the blue, green, and red channel, you can use cv2.split. So we'll see this later, and then cv2.merge to merge the 3 individual channels into one to make it a colored image again. Okay, so we'll see this in the demo later. Now to access image regions, you can just use like the range with coordinates. So if you want to access from y1 to y2, so this is the row, from row y1 to row y2, and then from x1 to x2, so this would be a region defined by y1, y2, x1, x2. Okay, and then if you want to change this certain region, then you can just also change it like this. So image y1, y2, x1, x2 is equal to the patch, assuming of course that these two regions have the same size, because otherwise there will be a mismatch and it will be an error. Okay, so just specify the coordinates, so the range of coordinates from y1 to y2, x1 to x2 of the region that you want to change, and you can plug in the value that you want to change later. Okay, so we'll see that also later. Now let's see some image arithmetic capabilities for OpenCV as well. So you can do addition. Now what will addition do to your image? So you want to do addition if you want a brighter image, because remember that pixel values are brightness values. So if you add or increase the image pixel brightness, then you'll use addition, right? So it will become brighter. So if you do something like image plus 20, then it will be 20 levels brighter than your original one. Okay, or you can also use cv2.add, adding two matrices together. And then for subtraction, it will do the opposite, right? So if you want it to be darker, then you do subtraction. So you can do like image minus 50, or use cv2.subtract if you have two matrices, then it will make the image darker, because you are reducing the brightness value, right? Now if you want to create the negative effect, okay, you're probably familiar with it, right? Like the negative film in the old cameras. So if you want to achieve that effect, then you just use 255 minus the image, because it will reverse or do the negative of the image. Okay, so I'll show you this later. Now you can also do things like blending two images together. Okay, so if you have two images and then you want to like blend them, you can use cv2.addWeighted. So you're basically adding the two images but with corresponding weights. So maybe 50-50, or maybe one image is more prominent than the other, so maybe use 75-25 as the weights. So I'll also show you this later in the demo. And then of course there are other arithmetic operations like bitwise operations. So you have bitwise AND, bitwise OR, bitwise XOR, bitwise NOT. So these are just the bitwise operations that you know already. And then for masking, like if you apply a mask on an image, you will use cv2 bitwise AND. So I'll show you an example of this later as well. And then finally, we'll now look at some of the transformations that you can do for OpenCV. Okay, so you can do translation, so meaning you move the image, like move it like 50 pixels to the left or 20 pixels down. So you use warp affine function for this one. So that's translation. So you move the image. Okay. Rotation, of course, is when you rotate the image. So first you need to use get rotation matrix 2D to get the rotation matrix, and then you'll also use warp affine, because these are just affine transformations. We won't get into the details of what affine transformations are, but basically you need matrix for the affine transformation. For the translation, you can build it like manually, but for rotation, you need to use get rotation matrix 2D. Okay, so that it will compute the rotation matrix for you. And then next you have resizing. So if you want to make it bigger, if you want to enlarge it, or if you want to shrink it, just use cv2.resize. Okay. And then for flipping, of course, you can flip it horizontally, vertically. You use cv2.flip. And then for cropping, if you want to crop certain areas of the image, then you can just use the image region manipulation technique that I mentioned earlier. So just use the coordinates y1 up to y2, x1 up to x2, and then just change however you like it. Okay, so yeah, that's the image transformation things that you can do. Now, there are other things that OpenCV can do that I won't include in the discussion, and that is saving video. So you'll actually learn about this in lab exercise later. So you can save videos from the video stream, but usually you can only save the video like with images without any audio. Okay, because this is of course just a compute like an image processing library, so no audio included. You can also do user interface components like sliders, track bars that you can use to maybe add some interaction in your interface. Okay, so you'll also get to experience this in later exercises or machine problems. And then also mouse events and mouse clicks. So you can do things like if you click on this part of the image, something will happen. So you can do that with mouse events and mouse clicks. So you'll also get to do this in later machine problems. Okay, so you can also do that in OpenCV. We just didn't discuss it in this lecture video. Okay, so of course there's a lot more things that OpenCV can do, but these are just some of the basic things, and the more important ones and the more common usage of OpenCV. Okay, so that's it for the discussion. Let us now go directly to the demos. Okay, so let's see. So okay, so for our first demo, for demo 1, this is loading, displaying, and saving an image. So before we go through demo 1, notice that we import CV2. So this is the OpenCV library, and then we import NumPy as NP. So this is the usual shortcut for NumPy, NP. Okay, so having imported these two modules that are which we'll use, then we're good to go. So for demo 1, as I mentioned, we will just load, display, and save an image here. So we will press S to save and any key to exit. Okay, so imread, you have the path to the image, so test.png. So test.png is this one, this red image with some lines. Okay, so by imread, then it will read it as usual. But if you pass in imread grayscale as a flag, then it will read it as a grayscale. Okay, and then we will use imshow to show the two images. So you name the window. So I'll name this colored and then grayscale, because if you name it the same window, then it will just display it in one window, right? So you have to name it two different things for it to display in different windows. Okay, so imshow, and then as I mentioned, you need to use wait key to pause the display, basically, because later on I'll show you what will happen if we don't have the wait key. Okay, so so what will happen is we will wait for the key press, and then we will store whatever is the key in there. But this will have like the ASCII code. So if we want to check if it's the pressed key was S, then we will use ORD of S. So this will convert the S into the ASCII equivalent, which is 61. I'm not really sure what the ORD of S is, but let's see. Print ORD of S. So ORD of S is, oh no, it has to be a string. It's 115. So that's the because the ORD of A starts at 97, right? And then if it's capital A, that's the 65. Okay. So going back, So if it's S, then we will save it. So to save it, we will do IMWrite, and then we will save it to test underscore gray. We will save the grayscale version. So right now, test gray does not exist yet. Okay, so let's run this. So we displayed the two, so colored and grayscale, right? And then if I press S to save, okay, going back here, now test gray has been saved as a new image. Okay, so let me delete that and do it again. If I just press any key, I won't press S this time. So it did not save it also because I did not press S. Okay, now going back, what would have happened if I didn't press this one, or I did not like do wait key? So what will happen is, yeah, did you see that? It just flashed and then disappeared right away. Right. So it showed, but then after that, it exited the function, so it just closed on its own. Right. The program finished. So for that not to happen, we have to use the wait key function. Okay, for it to basically pause, and so that we can see the image that we are displaying. Okay, so when we brought back the wait key, then it was able to pause. Okay, so that is loading, displaying, and saving the image. Okay, next let's see demo 2. Demo 2 is about loading and displaying a video. So I have here a test video. Okay, so test.mp4. So as I mentioned, we use cv2.video capture, right, and then pass in the path to the file. Now FPS here is 24. It's because this video has 24 frames per second. So let's go to the details. So here the frame rate is 24 frames per second. So that means that it has 24 images in 1 second. Okay, so to compute the delay that I want, so basically I will be pausing for displaying each image. I will pause for a while and then display the next image and then display the next image and so on. So to compute the amount of delay that I want, I would do 1000 divided by FPS. So meaning 1000 is 1000 milliseconds. So 1 second basically, divided by the number of frames per second. So 24 frames per second. So I would have, so what is 1000 divided by 24? So print 1000 divided by 24. That is how much? So 41. So 41 milliseconds. So after I display each image, I will pause for 41 milliseconds before displaying the next image in the video. Okay, so that is the purpose of delay. So later on, we will see also what will happen if I maybe increase the delay or shorten the delay. So what would be the effect of the displaying of the video? Okay, so we just have a while loop here, which is an infinite loop, and then I'll call video.read, so it will read from the video frame or the video object. So that's the video object here, and then video.read will return two things. So first is a boolean, which tells you whether there is still a frame to read or not, because if it has reached the end of the video or the stream, then it will yield false and you should now break out of the loop, right? So if it doesn't have any frame anymore, then you break out of the loop. And then the second thing that it returns is of course the frame or the image. Okay, so we'll use cv2.imshow for the frame. Okay, so you know that a video is just made up of a bunch of images, right? So what we're doing for the video is we get a we get a video object and then read the individual images off of that video stream. Okay, so we will show the individual frames, and then we have to delay for a bit before showing the next frame, right? So that's why we have the wait key with the amount of delay. Okay, going back here, wait key 0 means that you will wait for an infinite amount of time. So there is no limit as to the amount of wait that you will need to do. Okay, here if you specify a delay, like for example 41 or 50 or 20, then it will only wait for that amount of millisecond before proceeding to the next. Okay, so it will just pause for this specified amount of milliseconds before proceeding. Now we also want to listen to what the key press is, so that's why we get the key that it returns, and if that is Q, then we will also exit. So because we said press Q to exit, right? So if the key that we pressed was Q, so we use OR Q again to get the ASCII equivalent of Q, then we will also break out of the loop. Okay, and then after that, if we have broken out of the loop already, we will release the video so that it will be removed from the memory, because of course if you have a very big video, then that will be in the memory, right? And then after you're using it, then after you use it, then it's good practice to release the video to free up memory and for garbage collection to do its thing, right? Then after that, we'll also use destroy all windows, so that if there are any open windows out there, we would close them down. Okay, so that's displaying video. So I think I've explained all of it here, so let me show you the demo. So that is the video. Okay, it looks smooth, right? 10, 9, 8, 7, 6, and so on. So let me let me exit, or let me just wait for it to finish first. Okay, so it finished on its own because it reached the end of the frame, right? Now if I press Q at any point, so I'm pressing Q now. Okay, so it stopped as well. Okay, so you can exit early, because if you don't do this, if you don't have like an exit way, like a key to exit, then you will have to wait for the video to finish before it will stop displaying, because we have an infinite loop here, like while true, right? So it will, the only way that it will break out of the loop if you don't have this, right, is if the frame or if the video no longer has frames, which is still at the end of the video. But what if you have, like, let's say a 30-minute video, so you'll have to wait 30 minutes for it to finish, right? The other way that you could end it is if you force exit it by using the task manager or something like that. But having this checking the key press each time you do the delay is a cool little trick for you to be able to exit at any point. Okay, yeah, so I'm pressing Q again, I can exit. Now let me show you what will happen if we messed around with a delay. Okay, maybe I'll show you that in the demo 3 na lang. Okay, so that's demo 2. So if you have videos, again, don't forget to check the FPS. So in the details, there's 24 frames per second, and then to compute the delay, just do 1000 divided by the frames per second, so that it would be the appropriate amount of milliseconds to pause to before proceeding to display the next frame. Okay, so yeah, so that's demo 2. Now demo 3 is getting a live feed from the camera. Okay, so it's more or less the same as demo 2. The only thing that differed is basically instead of a path to the video, then you just pass in 0, so the index of your camera. So since I only have one camera, then this is the only one. This is index 0. Okay, so you'll notice it more or less has the same structure. The only thing that differed is I changed the video to camera here, but it's just a variable name. It's more or less the same. So camera.read, and then I will show the frame from the camera, and then I will just wait key for 1 millisecond before proceeding to the next, before basically getting the next camera frame. Okay, and then I still have the check. If I press Q, I will exit. Okay, and then I will still release the camera after exiting the while loop, and then destroy all windows. Okay, so let's run this. Hello. Yeah, so we can now display from the camera. Okay, so let me just exit there. And now the one thing that I wanted to show you earlier was, what if we played around with the delay? Like instead of 1 here, so I'm just waiting for 1 millisecond before reading the next frame. So you're actually reading 1,000 times in 1 second. So this might be too much. So maybe we'll just do that after 50 milliseconds. Let's see if it's still smooth. Right? So let's run that. And I'll move a little bit. It looks okay, but there's like a small like delay. Okay, but what if we change this to, let's say, 500, so half a second before reading the next frame? So what will happen now is, now it's very laggy, right? So I'm not doing this in stop motion. This is just really laggy because the delay is 500 milliseconds before reading the next camera frame. Okay, so if you even do 2 seconds, take 2000, then it would be really choppy now. Now I'm just doing like stop motion. Okay, so it would be better to do this at around maybe 40 to 50, so just like a 24 FPS thing. 50 still looks okay, right? So yeah, no delays, or yeah. If you want, if the most that you can do is 1, then it would be really smooth, but you're also reading 1,000 times per second, so which is very memory hungry. Okay, so that is the live feed from the camera. Let's move on to the fourth one. Fourth demo. Now this one is creating a blank image and doing region manipulation. So before we do that, so let me show you image 1 and image 2. So it's test and test2.png. So test is this one, so you've seen this earlier, and test2 is this one. Okay, some weird art that I made in Paint. So so those are the 2 images. So IMRead, you've already seen this, right? Now you can call image1.shape and image2.shape to get the shape of the image, basically the dimensions. Okay, so without looking at that one first, let's print the images of the the shape of the 2 images. So image 1, the size is 300 by 300 and it has 3 channels. Okay, same with image 2, also has 300 by 300 with 3 channels. So they have the same shape, so no problem there. Now what I want to do is display them side by side. Okay, so what I'm gonna do is I'm gonna create another image, but this time it would need to accommodate for both of them. So since they have the same height, then I'll just use their height, right? But assuming that without assuming that they are the same height, I would use the maximum height, because maybe what if one image was taller than the other one, right? So I would use whichever height is bigger, so I would use max between the two, and then for the width I would just get the width 1 plus width 2. Okay, so the width of image 1 and the width of image 2, and then I'll add them together because I'll display them side by side, right? And then now image 3 is the blank image that I'll be creating. So np.zeros with this shape. So the shape is the height that I mentioned here, the width, which is the sum of the two widths, and 3 meaning you have 3 channels. Okay, so and then I would pass in a parameter, data type is equal to np.uint8. So you need to pass this in to make it an unsigned integer with 8 bits because this is the acceptable data type for images in OpenCV. If you don't typecast it, I think it will like yield an error. So just if you want to create a blank image, then pass this parameter as well, np.uint8. So you're basically just converting the zeros to unsigned integer with 8 bits. Okay, so now I have the blank image. Let me see how it looks like. Okay, so I'll jump over this part first. I'll go directly to showing the image, so image 3, and then with weight key 0. So now, for now, it's blank because it's just pure black, right? So now what I want to do is I want to paste image 1 into the image 3, which is the side by side. So what I'm going to do is so this is image 1, right? The red one. So I'm going to start. So don't do this first. I'm going to start here from 0 0, right? And then so x1 and x1 and y1 is 0 0. So at the top left corner, and then the bottom right corner would be x1, so from here, plus the width of image 1, and then y1 plus the height of image 1 would be y2. Okay, and that would allow us to manipulate this region from y1 up to y2 and from x1 up to x2. And for image 3, this region, we will paste image 1's values. So if we do that, this is what is going to happen. Okay, so we pasted image 1 into the side-by-side image, but the image 2 is not yet here because it's still commented out, right? So if we remove this, then it's still just the black part, right? It's pure black. But if we manipulate the region here, then image 1 will be pasted. Okay, now if we want to paste image 2, then we cannot start at 0 0, because if we started at 0 0, what will happen is it will overlap, right? So it will do it here. So what we'll do is we'll start at wherever x2 is. So we'll start here, which is the x2 here. So this would be x2 and then 0. So the y1 is still at 0. And then the same thing for x2 is equal to x1 plus the width of the second image, and then y1 plus the height of the second image would be y2. And then do the same thing. So manipulate the region here. And then this one just means that all channels would be carried over as well. And then paste image 2. And if we do that, then we can now see them both side by side. Okay, so yeah, there's actually an easier way to do this, which is np.hstack. But I just wanted to show you how to do it by doing image region manipulation, because we can also do this in, I think, one line. hstack image 1 and image 2. And if we do that, let's try to display image 4. Yeah, you can do the same effect with just one line, right? hstack. But I wanted to show you this region manipulation thing, right? Or if you also want to display them on top of each other, then you use vstack, which is a vertical stack. Let's see if that works. So yeah, it stacked them together. Okay, so those are other tricks that you can do. Okay, so yeah, so that is demo 4. And then what else? The last one for the basics would be demo 5, which is all about drawing. Okay, so at the start we will have a blank image. This will be a 600 by 400 image, which is np.0, so it's all black again. So everything has been commented out, so let me just show you how it looks like for now. So I am show image, so it's just a blank image with all black. Now I want to turn this into white, so I will add 255, okay, to the image, and that will make it white. Okay, so it's now white. Now I will store in a variable called black the tuple 000, because this color I will be using a lot later on. So I'll just store it in a variable so that I'll just call the variable name if I want like a black color, okay, later on. Okay, so first thing that we will draw is a rectangle. So let's comment this out. Okay, so for a rectangle, you use cv2.rectangle. So you draw it in this image, and then you pass in the coordinates. So the top left corner, x and y, and the bottom right corner of the rectangle, also the x and y coordinates, and then the color of the rectangle, so it's black, and then the thickness of the stroke. So I'll just have this 2 for now. So after that, let's see what it looks like. So it looks like this. Okay, so there's a rectangle with black stroke, and then yeah, what if we made it 5, so it will be thicker? So yeah, it became thicker, the rectangle. If it was just 1, it would be like very thin, like that's the basic stroke. Now if you want to fill it up, then you use -1, so that's a fill. Okay, but for now let me just use 2. Okay, so I'll comment -1 for fill. Okay, so that's the rectangle. Now I'll draw some lines, and these are the lines that I want to draw. For now, so a line basically needs 2 endpoints, so the starting point and the ending point. So it will connect those 2 endpoints, and then the color of the line itself and the thickness of the stroke again. So very similar to the parameters for rectangle. Okay, so let me draw that one line. So it would be like this. Okay, this one would be like that, and then if I add the 2, it would be like that. Okay, so yeah, so those are the lines. Okay, so 4 lines. And then next is a circle. So we'll use cv2.circle, and then you pass in the image, you pass in the center point, so x and y coordinates of the center, and then the radius. This what is the radius of your circle? So how wide is your circle? And then of course the color of the stroke. And then this one I want to fill it with black, so I'll use -1. Okay, so I'll just remove the -1 for fill here. Okay, so for this circle, to look like this. So you can now see like a stick figure, a basic stick figure in OpenCV, right? Yeah, and then finally, the last thing that we'll put is a text. So text is hello world. Will indicate the starting point, the origin of the text, basically where you will start writing, and then the scale. So 1 is the smallest one, and then 2, 3, and so on. So I'll just put the scale to as 3. So you use put text and then image, the text that you want to write, starting at which point. So it's this coordinate here, and then you specify the font. So cv2.font Hershey plain. So this is the basic one that I'm using. There are other fonts that you can use as well, so just look for it if you want to know. And then the scale, and then the color. Okay, so if I write that, then it will display hello world here. Okay, now I want to save this in an image. So right now I'll just delete that, and then I'll run it, hello world.png, and then it's now saved as an image. Okay, so yeah, those are the basics for OpenCV. Let us now go to the second part of the demo, which is arithmetic. So image arithmetic. So we also have 5 demos. So let's start with the first one, which is addition and subtraction. So I'll just skip over the ones that you already know, like imread, imshow. Okay, so we've already discussed that in the previous one, the previous file. So I will use test4.png, which is the Batman image, and then I will use cv2.add to add brightness. So for the brightness, I'm creating a matrix here, np.ones. So this is similar to np.zeros, but instead of zeros, obviously it's filled with ones, right? So np.ones with the shape with the same shape as the image, and then specify the d type as uint8 as usual, and then we'll multiply it with 1000 so that the ones become not 1000 but 100, so that this will become a matrix filled with hundreds. Okay, similarly we have the same matrix here, np.ones, but this will just be multiplied with 75, so the matrix now is filled with 75 values. Okay, and then now that we have 2 matrices of the same shape, because we used the image's shape to create the matrix, so they have the same shape, so we can call cv2.add and cv2.subtract on the 2 matrices, which is the image and the matrix that we added. But basically this is the same as doing like image 1 is equal to image plus 100, or image 2 is equal to image 2 minus 75. So those are similar. Okay, and then for image 3, I mentioned the negative effect earlier. So 255 minus the image, so it will apply the negative effect. So let's show those 3 results. So this is the original one, this is the negative, right? So you're familiar with the negative effect. And then this one is subtraction, so we made it darker, right? And then this one is addition, so we made the image brighter. Okay, so pretty basic. Okay, so that's demo 1, addition, subtraction. Next is blending. So for blending, what we'll do is test.png and test4. So the red one and the Batman. Okay, but before that, let's display their images, the shape first. Okay, so for us to be able to blend or blend 2 images together, they must have the same shape, they must have the same size, because if you do this like add weighted without doing any resizing, then it will yield an error, or sorry, gamma is should be here. Yeah, it will yield an error. So the error here is the operation where arrays have this have same size, they need to have the same size. So there's an error here because the 2 images don't have the same size, right? They don't have the same shape, because the first one is 300 by 300, the other one is 700 by 700. So for us to be able to blend them, you must first resize the other one. So let's make the two bigger. Let's make image 1 bigger. So resize it to 700 by 700, and then just pass in interpolation interlinear. So it's just a flag that you need to use, right? So I resized image 1 to be 700 by 700. So if I put it over here, their shape, they now have the same size. Okay, so there shouldn't be any problem here now. Okay, so with that, we can now blend them together. So we just set gamma as 0, so you don't need to worry about that parameter. So you use add weighted for image 1, 50%, for image 2, 50%. So there's 50-50 of the two. Okay, so we're blending them together with equal weight, and then we'll display it. So let's see the result. So yeah, it looks like this. So we blended the two images together with equal balance. But what if you want Batman to be more visible? Okay, so if you want to do that, Batman is test 4, right? So Batman is image 2. So if you want to increase image 2, so this will be 75. So we'll have to reduce also image 1. So this will be 25. Okay, so 75 for Batman, 25 for the red thing. So Batman is now more visible. The red thing is like faint na lang. Okay, if you want it even more extreme, like 90 and then just 10%, then it, I don't know if you can still see it, but it's really faint na lang ang red. Okay, now if you want to do the opposite direction, 9 or maybe just 8 and 2, 80-20. So it's the red one that's very visible, and then Batman is just like a faint background. Okay, so you can experiment with the weights however you want it to be. Okay, as long as they add up to 100%, of course. Okay, so for now, let's revert it back to 50-50, and that should be the result. Right? Okay, so equal weight. Okay, so that's for blending. So take note that we used add weighted here. Okay, and then specify the weights. Now for the third one, we'll look at bitwise operations. So for demo 3, so we'll be reading this circle and this rectangle, the two images, and then I'll read them as grayscale because those are just black and white, right? So I don't need them to be colored. I just want them to be grayscale. So it will just be one channel only. Okay, so rectangle and the circle, and then I'll be doing bitwise not, bitwise and, or, and XOR. Okay, and I'll just display everything. So let's just show everything now. Okay, so here's the rectangle. Okay, here's the circle, right? And then this is the knot of the circle, so it just reversed everything, right? So whatever was black became white, whatever was white became black. So knot, basically flip it. Okay, next is the bitwise and. So the and is the intersection of the two. So you took the rectangle and the circle, and if you add them together, this is the result. Okay. Okay. Next, the or is the union of the two. So we just combine the two together, and then there's the rectangle there as well. Okay, next is the XOR. So the XOR is the union minus the intersection, right? So this was similar to the union, but the intersection was removed. So you'll notice it's black in the middle, right? So that's XOR. And yeah, so that's it. So those are the bitwise operations. So pretty simple. Next is masking. So a mask of an image. Okay, so for this one, what we'll do is we have Batman as the test image again, test 4, And then we'll use the rectangle and circle as the mask, and then I'll read them as grayscale again. And for masking, we'll use bitwise and we'll pass the image as both images. So remember from here, bitwise and was needed two images, right? So earlier we found the and of the rectangle and the circle, but here we will apply and to the same image. So it's basically the image still, but we will pass in a mask with the rectangle. Okay, so whether it's the rectangle mask or the circle mask, so let's just see what happens. Okay, so this one is the image with the rectangle mask applied. So with the rectangle mask, we now only see this part of the Batman because this was the rectangle earlier, remember? And then for the circle mask, then it will just only apply this mask, and then the only visible part would be the ones covered by the circle, basically. So that is how you apply a mask onto the image. Okay, so if you want only certain parts of the image to be visible, then apply the mask. Okay, that's how you do masking. And then finally, the last one is about splitting and merging channels. So for test2.png, it's this one, right? So so the image now has 3 channels, right? So if you want to get the individual blue, green, and red channels, we'll have to use cv2.split to get the 3 individual ones. And then I'll show the 3 individual channels on their own what do you call this, in their own windows, and then you can use cv2.merge to merge the individual channels back into a colored image. And so I'll show this merged version in the merged window. So let me show you the result. So this is the merge. So this is the basically the original one, right? For the red channel, you'll notice that it only has white on the parts that have red, basically, right? So this one has red. This one has red. This one fuchsia has red. This one also the yellow. That one has red, and of course the white. And then for the rest, it doesn't have any red. Okay. Now for green, the white part only is green, yellow, aqua, and the white. And then for blue, of course, you have blue, aqua, white, and then the magenta. Okay, and then the rest has black because it's 0 on these parts, right? So you can look at the individual channels if you want to. Okay, so that is splitting and merging channels. Okay, so we're done with the image arithmetic, and we'll now go through to the last part of the demo, which is image transformations. So first we have translation. So translation again is moving. Okay, so for the movement, we'll move down and right. So this one is 25 pixels right and 50 pixels down. So this is the translation matrix we need to create. So np float 32. 10 means that we're doing it to the right, so 25, or basically on the x-axis. Okay, so 25 means that you're moving 25 pixels forward, so this is to the right. If it's negative 45, that means that you're going backwards, so that's 45 pixels to the left. Okay, and then on the 0, 1, this means that you are on the y-axis, and then 50 means that you're going down. Minus 90 means that you're going up. Okay, so and then you use warp affine, pass in the image, pass in the matrix, and then the width and the height of the image as the parameters. And then let's display everything. So yeah, so this was moved to the downwards and to the right, and then this was moved upwards and to the left. Okay, so that is the translation of the images. Okay, so you move them. Next is rotation. So for rotate, we'll need to use get rotation matrix 2D, and then we will need the center. So width over 2, height over 2, so that would be the middle part of the image, right? Because width over 2 is the center of the x-axis, and then height over 2 is the center of the y-axis. So that is the center, and then the scale is just 1, and then you get the rotation matrix by using get rotation matrix 2D, 45 degrees, and then negative 90 degrees. Okay, so 45 degrees is 45 degrees counterclockwise, the negative 90 is the clockwise direction. Okay, and then you use warp affine still with the matrix, and then width and height, and the same thing. Okay, so let's see the results. So it's the original, and then rotate 45 degrees counterclockwise is doing this, and then rotate 90 degrees clockwise, it's doing this. Okay, so from here it became flipped like to the right. Okay, so rotated 90 degrees to the right. Okay, so that's rotation. And then of course you'll notice that for the blank spaces here, it would be black. Okay, it would be left as black. And then those that are exceeding the boundaries of the image would be cropped out. Okay, so that is rotation. Next is resizing. So for resize, so if you want to like use like 75% or 200%, okay, so if you want to shrink it, of course it has to be lower than 100. If you want to enlarge it, then it would have to be bigger than 100. So you can do this in two ways. You can specify the size, the new size, the resize dimensions explicitly, just like what we did earlier in I think arithmetic. We did that here, right? So if you specify the size explicitly, then it will give you that size. And then if the aspect ratio is messed up, then well, it is what it is, because you specified the explicit dimensions. So if it has a different aspect ratio and then you force it to become 700 by 700, then the image might become warped, right? It might become weird looking. But if you want to preserve the aspect ratio and you just want it to enlarge it or shrink it by a certain amount of percentage, then we'll use fx and fy. Okay, so the new size, you'll just leave it any value that you like, because if fx and fy is specified, this will be prioritized. Okay, so I'll just pass in 0 0 as the new size, because it will just ignore this because I am passing in fx and fy. So meaning I will be shrinking this 75% along the x-axis and 75% along the y-axis. So you can also do like 75% on the x, and then you stretch out the y to be 200%. It will look weird, but if that's the effect that you want, then it's up to you. Okay, so interpolation, inter area, or interlinear. So these are just some of the common ones that you use. Okay, so let's try one more thing here. What would happen if we do this and fx is, let's say, 0.5 and fy is 1.5. Yeah, so this will become weird. Okay, so I'll call this weird. It's image 3. Okay, so let's show that. So yeah, this one looks weird. So this was the original. I shrunk it down to 75%, so it looks the same. It's still a square. I enlarged it. It's still a square. But then this one got shrunk. So it's not the same square anymore, and then it got stretched on the y, right? So it's not a square anymore because of the percentages that you specified here. Okay, so that is resizing. Next is flipping. So flip is pretty straightforward. Okay, if you want to flip it horizontally, then flip it on the 1. If vertical, flip it on 0. If you want to flip it on both sides, it's -1. So it's just the result. So this is the original. Okay, if you flip it horizontally, then it will mirror it on the other side. If you flip it vertically, then it would be flipped down, upside down. And then if you flip it both ways, it would be mirrored and flipped upside down. Okay, so those are the flips. And then for cropping, just use region manipulation basically. So we read the image and then we specify the region that we want to crop out. Okay, so image 1 is equal to that one. So this is the part of the image that we access. Okay, so let's show the two side by side. Okay, now if you want to block that out, then we'll just use how will we do this? Is equal to, can we do equal to 0? Probably not, right? Yeah, we can do it. So okay, so when we block that out, yeah, it was removed. Okay, so if we remove that one, it will get this part here. Okay, so that is cropping. And then what else? Last is the converting to color space, which is pretty simple. If you want to convert it to grayscale, you have convert color and then pass in the flag BGR to gray. If you want to convert it to HSV, then you use BGR to HSV. If it's lab color space, then it's BGR to lab. Now, I will show you the images, but the image itself does not make sense, or like the colors itself don't make sense, because the displays are supposed to be in BGR or RGB color space. But since we converted it into different color spaces, then the colors would look weird. Okay, so like, yeah, in here. So the grayscale is of course in grayscale, but then the lab and HSV looks kind of weird because it's in a different color space, as I mentioned. And the image displays are expecting you to express the images in RGB format. Okay, so yeah, but this is how you convert it into different color spaces. Okay, convert color and then pass in the flag. Okay, so I guess that is it for the demos. I will also be making this code available to you so you can study it if you want later on. Okay, so going back here, so that is it for this video. For our next topics, we will look at image processing, so more processing for the images. So we'll look at histogram equalization, thresholding, morphological transformations, and filtering. Okay, so those would be our next topics. And if you have any questions for OpenCV or anything that we discussed today, please don't hesitate to ask, and I will see you next time.